Welcome back. We are going to talk about the transient response specs of a first order system. So let me write this down here. Transient response specs, specifications or specs. Transient response specs of the first order system. Specs of the first order system. The first order system. Now, what do we mean when we say transient response specs, such as the time constant? We are going to talk about what is that. We are also going to look at the rise time, and we are going to look at the settling time. Settling time. So these are the three specs that we are going to look at for the first order system. So let's say we have a first order system which is A over S plus A. Now all these videos that I put out here after somewhere around 14 or 15 for homework assignment number 2. So this is going to help you with the problem 1. So let's just discuss about this. Now this is the transfer function GFS, and as you recall, this is the reference input RFS, and here is your output response. So we can simply say that CFS, as you know it by now very well, is just simply going to be RFS times the GFS. And as usual, we are going to take as a unit step function for the reference input. So the CFS is simply going to be 1 over S, and this is going to be A over S plus A. Now we can apply what we call is the partial fractions to solve this, so that we can solve this in the time domain, and you pretty much know how to do this now. So just as an exercise, you will find out once you do it, A is equal to 1 and B will be equal to minus 1. So if you do that, then CFS will simply be equal to 1 over S minus 1 over S plus A. Okay, so to take the inverse Laplace transform of this, try to keep it right here because I would like to discuss the plot on the left-hand side of the system response here. So the response, the output transient response C of t, if we take the inverse Laplace of this guy, inverse of this guy, inverse of this guy, as you know it by now very well, 1 over s is just 1 and minus e to the power of negative at. So if you recall, this portion is called the forced response, and this is called the natural response. Now, the values that we are looking for is the time constant, and the time constant, if you look at this, time constant Tc in this is equal to 1 over A. So if you come out right here, this is, I'm going to put this in the red format. So this is equal to 1 over A, and the value of the time constant at this point is 63% of the final value. So the time constant is like how long does it take to reach the 63% of the final value. So how do we define that? You can see the time constant Tc is equal to 1 over A, isn't it? So here we got one parameter nailed down here, and I can write Tc is equal to 1 over A. How long does it take to get to the 63% of the final value is called the time constant. So we got the time constant, and this will really help you in solving problem number 1. And then we are going to look at the rise time. Well, if you look at the rise time, the rise time is starting somewhere around here and going up to there, right? So we can say that the rise time, TR, is equal to, we are somewhere around here, 2.31 divided by A minus, and this is right here is 0.11 divided by A. So the rise time, TR, will be equal to 2.2 over A. And this is coming out from this graph, as you can see. This is called the rise time. Well, how about the settling time? TS is the settling time. And you can see the rise time is the time it takes for the signal or for the response to get from 10% to the 90%. And you can see this is 0.9, this is 0.1. And the settling time is actually when it reaches to the 98%, and that's somewhere around 4 divided by A. So we got all the three specs now, so we can write it down here. So the rise time, TR, as you can see from the graph there, the plot, is 2.2 divided by A, and let me write this as the rise time. Okay. And the settling time, TFS, is just simply equal to 4 divided by A. Well, let's take a look at a problem to find our settling time and the rise time. So suppose I have a problem like this, where I got a transfer function of a system. This is a first order system. Let me write this down. We are still talking about the first order system. This is all first order system. And let's say that we have a transfer function of 10 over s plus 10. Well, you know here a is equal to 10, isn't it? A is equal to 10. And we can find, since we know the value of a, we can find all these values. We can find the time constant. Time constant will be just simply 1 over 10, which is going to be 0.1 seconds. And then we have the rise time, which is going to be 2.2 divided by the A, which is 10, right, which is 0.1. So if you do that, that will be 0.22 seconds. And last but not the least, TS, which is the settling time, is going to be 4 over A, which is going to be 0.4 seconds. Now we can also apply an input of, let's say this is R of S, and we can say this is equal to 1 over S, and here we can get the output C of S. So as you can pretty much see it now, I think you kind of know how to do this. We are going to have to apply to find the output response. Well, we know that this is coming out to be 10 over S plus 10 times the S. And we have to do the partial fractions here. So that will be A over S plus B over S plus 10. So if that's the case, my friends, we can write this as 10. We've been doing this for a long time now. A times S plus 10, and this will be the BS, right? So if S is equal to 0, we get the value of A is equal to 1. And if S is equal to minus 10, then we get the B of as minus 1. So if you will, you go ahead and plug those in, and we can find the response by taking in time domain by taking the inverse Laplace transform. So this is minus 1 over S plus 10, and you will see you are going to get a forced response and a natural response because you have a pole at 0 and you have a pole at minus 10. So C of t is simply going to be equal to 1 minus e to the power of negative 10t. Now you see that as t goes to infinity, all you will be left is with the forced response and system is stable. And this part is known as the natural response. So with this, you should be able to solve problem number 1 on your homework assignment without any trouble. And I will get back with you shortly in the next video talking about the second order